Hello everyone. Welcome to the Electric Automation Breakout Session. I am Tom Warsnop, Product Market Manager for Electromechanical Actuators, Servo Drives and Motors, as well as PLCs, HMIs, and Motion Controllers. So let's start with a bird's eye view of the electric automation product range. What do we have to offer our customers? We have a wide range of electric actuators, including rodless linear actuators, cantilever actuators, electric rotaries, mini slides, and electric cylinders. We have a great range of servo drives and motors, including AC servo drives and servo motors, as well as our DC servo drive and stepper motors. We also have the Simplified Motion Series axes, which combine our low-cost actuators with an integrated motor drive. That's going to be the focus of this session. We have a wide range of Cartesian handling systems, and we have the servo press kit. We also have system peripherals, including PLCs, HMIs, and vision sensors. And lastly, we have decentralized I/O. So next, I'm going to cover the enhancements to the Simplified Motion Series. And after I present the enhancements, I'll show you some of the ways that customers can take advantage of them. So last September, we released 2 upgrades to the SMS product line. The first was the addition of parallel kits. And the second upgrade is the ability to do flexible positioning via IO-Link. First, let's look at the parallel kits. This upgrade affects all of the ball screw axes, including the EPCS electric cylinders, the EGSS mini slides, and the ELGS ball screw linear actuators. Until last September, the only option for motor mounting with these 3 axis types was to use an axial kit. And that means the motor was always sticking out of the back of the axis. And that means customers who didn't have space couldn't use these SMS axes. Now they can. With this upgrade, customers can mount the motor in almost any direction, and they can orient the cable connectors in almost any direction. There is an exception on the ELGS ball screw linear actuator, where you can't mount the motor on the top side. So the benefit to our customers is pretty straightforward. It is the convenient motor mounting options that we now can offer. The other enhancement to the SMS axes is the ability to do flexible positioning. And what I mean by flexible positioning is the ability to move to any position along the stroke length. Let me show you an example of what I mean using the EPCS electric cylinder. As you can see, it's possible to move the axis to any position along its stroke length. And we can change the speeds for each of those movements. So with this upgrade, it's possible for customers to use the SMS axes just like a traditional electric axis. And this is a huge improvement to the functionality of SMS axes. Before the firmware upgrade was released last September, SMS axes could be used for end-to-end positioning, like you see here. And this kind of movement is perfect for applications where our customers are replacing a pneumatic actuator, or any application where they only need to move between 2 positions. In these cases, the customer can configure the extend speed and retract speed during commissioning, but they can't modify those speeds on the fly. And for customers who needed additional flexibility, SMS axes didn't used to work for them. So let's compare the old end-to-end functionality with the new flexible positioning functionality. With the old functionality, customers could move between two positions, like this. And they could configure the extend and retract speeds during commissioning, so those speeds don't have to be the same, like this. Once those speeds were configured, though, customers were not able to change them on the fly during operation of the axes. With the new functionality, however, the SMS axes can move to any position and change the speeds on the fly, like this. So next, let's see how this enhanced functionality applies to a couple of applications. This first application shows a diverter using an ERMS electric rotary. In this first case on the left, the customer is using end-to-end positioning to sort two products onto different conveyors. In this case, the ERMS is moving between 0 degrees and approximately 45 degrees. And these two positions and the speeds of rotation, that would all be configured during commissioning. And then during operation, those positions and speeds would not change. In the second case on the right, the customer is sorting three products into three different lanes. In this case, the ERMS has to rotate to three different positions. So that means end-to-end positioning isn't enough. With the new SMS functionality, though, this is possible. In this second application, the customer is using an EGSS mini slide to assemble two components by pressing them together. In the first case on the left, you can see that the EGSS axis is assembling the same two components the same way every time. This process doesn't require any kind of flexibility in force level, positions, or speeds. And so when the customer sets up the axis during commissioning, they can specify the force level, they can teach the start press position, which is where the axis moves to before it switches into force mode, and they can specify the extend and retract speeds, but they can't change any of those parameters during operation. In the second case on the right, what we're seeing here is a much more intelligent automation solution. There are three different scenarios the customer is anticipating. An assembly with a short component, like you see here. An assembly with a taller base component, like you see here. And basically a mistake, where there should be components, but they are missing. So as these components are coming down the conveyor, the customer needs some way of identifying each scenario. So maybe they're using a vision sensor off to the side, like this. And the vision sensor detects whether both components are in place, and it checks the height of the components. And then the PLC uses that information from the vision sensor to tell the EGSS axis what height to move to and what force to apply, assuming the assemblies require different forces. And if the vision sensor doesn't detect both components, then the PLC doesn't send any commands to the EGSS and it skips doing the assembly. And this kind of application is only possible with SMS because of the new functionality that lets the customer modify the force level, change the height, and specify the speeds for each and every movement. So with the new functionality in mind, let's consider how customers can control SMS axes with their PLC. There are three primary ways to do this. The first option is to control the axes via digital I/O. A second option is to use IO-Link via the CPX API. And a third option is to use a PLC with an IO-Link master or to use third-party IO-Link modules. All of these methods have advantages and disadvantages, so we're going to look at each of them in more detail. For digital I/O control, our customers need a PLC with at least 2 digital inputs and 2 digital outputs. It can be a Festo PLC, like the CPX-E CEC with an input module and an output module, like you can see here. Or it can be a compact Logix PLC from Allen Bradley with integrated I/O, like you see here. Or it can be almost any other third-party PLC on the market as long as it has digital I/O. Next, the customer wires the SMS axis to the PLC, like you can see here. So as you can see, there are 2 inputs and 2 outputs from the SMS axis. The 2 inputs to the SMS axis are used to command the movements, and the 2 outputs from the SMS axis indicate when it's reached the end positions. And with that, our customers can easily control the SMS axis for end-to-end movements, like this. So as you can see, it's just a simple handshake between the PLC and the SMS axis. Okay, let's consider another aspect of control with digital I/O. How many SMS axes can be controlled simultaneously? This depends entirely on how much digital I/O is available on the PLC. In this case, with a CPX-E CEC, a customer can connect up to 6 output modules and 3 input modules, which is what you can see here. And that would allow them to control up to 24 SMS axes via digital I/O. So the simplicity of SMS and the need for only 2 inputs and 2 outputs gives our customers a lot of flexibility when using SMS axes with digital I/O. In the next case, the customer wants to use a PLC with Fieldbus, like this CPX-E CEC, which supports both EtherCAT and Modbus, or maybe an Allen Bradley PLC with Ethernet IP, or a Siemens PLC with Profinet. In order to use Fieldbus control, we have the CPX API with 2 modules. The Fieldbus module on the left connects to the PLC via Fieldbus, and the IO-Link module on the right connects to the SMS axis via IO-Link. So this is the basic setup for using an SMS axis with CPX API. And because it uses IO-Link, the customer has access to all of the parameters, and they can do flexible positioning, like you can see in this video here. Also with this setup, customers can use up to 4 SMS axes per IO-Link module. And if customers need additional SMS axes, then they can simply add more IO-Link modules, like you can see here. So with the CPX API, theoretically, customers can control hundreds of SMS axes from their PLC. The real limiting factor in that case is whether the customer's PLC is powerful enough to control that many axes. And I'm really looking forward to one of you finding that application that uses the hundreds of SMS axes with a CPX API network. Another benefit to using the CPX API with SMS axes is that it's easy to extend the CPX API network across long distances. For example, consider this conveyor line for packaging bottles. There are various machines spaced out along the conveyor to handle different aspects of the packaging process. Using CPX API, the customer can easily distribute SMS axes wherever they are needed along the conveyor. And the customer's PLC can control all of them from a centralized cabinet. So this same principle can be applied not just to conveyors, but to any large machine with SMS axes, where the SMS axes need to be used in different locations. So what can we do to make this as easy as possible for our customers? The first thing we have are application notes and function blocks. And these make it significantly easier for a programmer to get up and running. We have an app note for Rockwell that shows a customer how to set up the hardware and how to use the included add-on instruction. We have an app note and function block for Festo PLCs, as well as other Code Assist PLCs. And we have the same for the Siemens PLCs. In addition, we also have videos on YouTube to show customers how to use SMS with CPX API. The first two videos on this list were put together by one of our application engineers, Tim Doyle. In these videos, he shows how to create a program and how to use the SMS add-on instruction. So thank you very much for putting those together, Tim. Great job. The third video shows how to wire the SMS access for IO-Link control, and the last two videos show how customers can connect to a CDSU IO-Link master and how to wire SMS axes for digital I/O control. So where can customers find the application notes and function blocks? First, go to any of the SMS access landing pages. Here I'm showing the web page for the EPCS electric cylinder. Then scroll down and click on the support and download section. Scroll down again and go to the expert knowledge area. And that's where customers will find the application notes and function blocks. Next, let's consider the third way to control SMS axes. In this category, I'm including PLCs that have onboard IO-Link modules, like this CPX-E CEC shown here. And I'm also including other third-party IO-Link modules on the market, like this Allen Bradley Remote I/O module and this Balluff 16-port IO-Link module. This group of products still uses IO-Link to control the SMS axes, so they get all of the benefits of IO-Link, including flexible positioning and access to all of the parameters. But in most cases, there are no application notes and function blocks, so from a programming standpoint, these will require the most effort from the customer. So you may have noticed there's an asterisk on the Allen Bradley 1734 AENTR.IO module, and that's because help is available when customers use this module. There's an application note and an add-on profile available in the support portal in the same place as the other application notes and function blocks. And there's a video on YouTube showing how to use them. This was put together by Steve Proud, and he just updated the content to include the new functionality. So I just covered a lot of content about these three methods of controlling the SMS axes. So let me sum it up in a nice table. In this table, I'm comparing the three options for controlling SMS axes. First is the digital I/O control. Second is IO-Link control with CPX API. And the last option is IO-Link control with either a PLC or with third-party IO-Link modules. For end-to-end positioning, digital I/O as well as all of the IO-Link methods support this feature. For flexible positioning, as well as parameter access, including the ability to change position, speed, and force levels on the fly, this is not supported with digital I/O control, and it is supported via all of the IO-Link methods. Next, how easy is it for the programmer to control SMS axes? For digital I/O, it is very easy. It's just like programming the movement of a pneumatic actuator. For IO-Link via CPX API, this is also fairly easy for a programmer, and this is because we provide the AOI for the Rockwell Studio software, as well as function blocks for Festo PLCs and Siemens PLCs. For IO-Link directly from a PLC or via third-party IO-Link modules, this is the method that takes the most effort, since we don't offer function blocks for most of these. So the programmer has to do all the programming if they want to access the parameters. The exception there being the Allen Bradley Point I/O module, for which we do have an app note and an add-on profile. And lastly, how much do these different options cost? Digital I/O is definitely the lowest cost option. Customers can use the cheapest PLC and no additional hardware is required. They don't need an IO-Link module. They don't need a Fieldbus gateway. For the IO-Link options, I've listed the CPX API as the most expensive option, ? And if you're comparing just an IO-Link module with a comparable CPX API solution, then it typically is more expensive to use CPX API. However, the amount of flexibility that the CPX API offers may end up making it cost less, especially if the customer is using CPX API for other devices, like additional I/O or for valves. Next, I want to show you an interesting application. This application uses the EPCE compact electric cylinder to do a vertical form, fill, and seal application. And the way that the vertical form, fill, seal process works is exactly as described. The machine forms a bag, fills the bag with product, and then seals the bag. The way this happens is really cool. Plastic wrap is fed into the machine as a flat sheet. You can see that here. It is then wrapped around this filler tube that you see here. Then the edges of that plastic tube are heat sealed. You can see the edge here, and then they're sealed on the bottom by the heat sealers down here. Once you have that sealed plastic tube, product is dropped through the filler tube into this sealed plastic bag. The entire tube is moved down, and then the heat sealers seal the top of that bag, and voila, you have a heat sealed bag of product. So let's take a look at the video of this process with the EPCE actuators. These are the heat sealers, EPCE actuators on the side. You can see that's the product. They just sealed the bottom of that bag. Now they're sealing the top. This is going to seal the sides. This video is available on YouTube, and I've included the link. If we take a closer look at the heat sealers, we can see the vertical ones here, the horizontal ones are here, and all four of these are being actuated by the EPCE actuators here, 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 and here. Now, I don't know the details of this application, but it's clear from the video that the EPCE electric cylinders are being used for end-to-end movements. And since the heating elements have to be pressed together at the end in order to seal the bag, I'm assuming that they're using the EPCE in pressing mode, where they're pre-positioning almost to the end of stroke so they get that fast movement, and then switching to force mode for the last few millimeters of movement so they can press the heat sealers together. That can all be done with the base functionality of the SMS axes, so they could be controlling this with digital I/O, or maybe they're using IO-Link in order to access additional parameters. The other thing I want to point out is that the customer is using third-party external guiding with the EPCE axes. You can see the heat sealers mounted to these here. That is the external guides. And so just keep in mind that even though we don't offer external guides for the SMS electric cylinders, our customers can always use external guiding from another supplier. And lastly, headquarters liked this application so much, they made an animation of it to show it off. So it's got the 4 EPCE cylinders, the external guiding, the heat sealers on the side and on the bottom here. And you can see the whole process, right? It creates the bag, drops the product in, seals the top of the bag, and repeat. Next, how can our customers size SMS axes? First, go to festo.com/SMS. Then scroll down until you get to the Solution Finder. Click on the Configure button. This will open the SMS Solution Finder webpage. Enter the application information on the left side of the page. This will include things like the movement type and the actuator type, the mounting position and stroke length, and so on. And then you select a solution from the results on the right side. Click the Buy Now button, and you're done. Thank you very much. And if you have any questions, we're going to do a Q&A right now, or feel free to contact me afterwards.